I'll reshare my screen. Okay. All right, looks like we're all good. So welcome everybody. I'm gonna keep bringing people in. Welcome to July. It is incredible that we're already so far into the year and don't have fantastic weather yet, but I'll keep my fingers crossed for it. We had some great weather on the weekend. As I was telling Manjunath, I was painting all weekend, so I didn't get to see much of it, but hopefully next weekend I get out and get to enjoy some of that. So without further ado, I'm going to move everybody right into the session as quickly as possible. Welcome to DevOps Toronto. If you haven't been to our Slack, you can see that link right in the middle lower section of the slide. That's where a lot of conversation happens on a regular basis. If you're not in there and you've got challenges, questions, ideas, or if you just want to connect with other folks in the community, that's the place to go. So jump over there, take a look. If you haven't recently, it runs when we're not having these events. So you can get in touch with anybody across the ecosystem, which goes well beyond Toronto at this point. But I encourage you to check it out. Also encourage you to check out our sponsors. CloudBees, been with us for quite some time. If you don't know them, they run end-to-end DevOps toolchain for CI/CD. And they do a ton of stuff. They're gigantic. If you've got build and release challenges, you should check them out. Also, BMC, a big player in the marketplace. If you're a larger enterprise and you've got complex challenges, I would check them out as well. They're working on a lot of different problems, but they come out of this sort of data space. And also JFrog, our longest standing sponsor. They are in the artifact space, but really build and release engineering tooling. So also an incredible community member. They're always around to talk to about anything DevOps and anything tooling related. With that, I'm going to hand off to Manjunath, who's going to tell us about unified monitoring and the challenge of stitching together data from all kinds of different places to get a unified view of what's happening in your ecosystem, which is so critical nowadays when we have so many tools for so many different pieces of the puzzle. And it's a big problem to try and pull that all together. So without any further delay, I will hand off to Manjunath and let him take the screen.
Sounds good. Thank you, Steve. Just let me know when you can see my screen, please.
We can. You see Zoom screen. There you go.
Let's get started. Good evening, everyone. My name is Manjunath Venkatram. I'm the founder and CEO at ThoughtData. And thanks you for taking time to join on this session. And I'll be talking more about unified IT monitoring for DevOps in this session. And just talking a little bit more about myself and my background, about 22 years of experience in enterprise IT monitoring. I worked across network performance monitoring, application infrastructure performance monitoring, and cyber threat monitoring. Those are core areas of expertise. And primarily, I spent about 15 long years in research and development, started in 2000s in a company called as Network Associates. Today, they are called as McAfee. During those days, they were called as Network Associates. I started there as a research and development engineer. I did software development, quality assurance, product management, and then moved on into sales. Spent about 16 long years. The company kept on changing hands, Network Associates to Network General to NetScout Systems recently. And then I founded my own company in 2019 to solve a unique problem in the industry, which is the unified IT monitoring, which we're going to talk about. So since last 3 years, I've been an entrepreneur. I recently started writing blogs as well from last 6 months, and have been an avid speaker on various technological related topics. So that's about myself. The problem, as many of you are very, very comfort, or have seen this, is applications are extremely important in enterprise businesses today, and unplanned applications downtime and poor performance of these applications can be very, very problematic for enterprises businesses today. And even a single minute of IT downtime can have significant disruption to productivity, customer satisfaction, revenue, and even brand reputation. And these issues, when you're troubleshooting in a DevOps environment, are extremely complex to solve because there are several moving parts in an IT related environment, right? And you need so many different kinds of data sets for you to understand the problem, the impact of the problem, and finally find the actual root cause. And when you look at from a customer standpoint, the symptoms of the problem starts with customers who are using the application. Either the application is failing or the application is poorly performing. One of those two things actually start. The problem could be in the application itself, the way it is designed, developed, deployment, and how it is performing. The problem could be due to a infrastructure related issue on the server side, whether it's a physical infrastructure or a virtual infrastructure. The resources may not be available for the applications to perform properly. Microservices architecture, there could be several problems. Cloud-based infrastructure, there could be several issues going on. Network is another key component where there are several problems related to bandwidth, congestion, latency, errors. There are several issues which can occur on the network related side as well. And last but not the least, today's world, cybersecurity is extremely important. And if there is a cyber-related threat going on within the enterprise IT data center, and there could be several problems originating from those cyber threats, they can be having a lot of issues on application, infrastructure, as well as on the network. So when you are trying to troubleshoot, when you get a ticket in a DevOps environment, you need so much amount of data in order to understand the problem, the impact of the problem, and the actual final root cause. So that's what we're going to focus today. We'll look at how you actually triage an application performance issue end to end in a DevOps kind of an environment. What kinds of monitoring data sets are actually possible? Various kinds of tools are actually available in the market space, and why you need a unified visibility is what we're going to focus on. And what are all the challenges? You will be facing challenges within your own DevOps teams. You will have org level challenges, process level challenges, tool level challenges, right? There are several related challenges which you face when you are trying to address a problem and trying to find a fix for it. And what you need to consider, right, when you're considering tools, what are all the things as a DevOps and SRE team, what you need to consider while making the right decisions for implementing those tools. And we'll focus on the unified IT monitoring. Why is it important? And if there is time availability, and if I have about 5 minutes time at the end, I can actually show you a working problem end to end on an application performance, how to solve it end to end with unified visibility. And then we'll start with Q&A. So let's dive in and let's look at how an application problem occurs in a DevOps environment. So here I've taken an example. The customer is on the left-hand side, the applications and the data center and everything is on the right-hand side. From a customer standpoint, there are only two things which can occur. Either the application is failing, he is not able to use the application at all, or he is able to use the application, but it's extremely slow, right? So one of these things is occurring on the user side. When it comes to the enterprise IT data center, so initially there is going to be a web proxy server. I'm assuming it's a web-based application here. There is a load balancer where all the connections actually come in. And in the back of the proxy and the load balancer, there are several servers. I've taken only for simplicity one server here. There could be several which are load balancing the connections depending on traffic. And the application infrastructure could be a multi-tier architecture. The front-end web-based application, there is a middleware component, there is a distributed database, and there could be several dependent application and integrations which you would have done, where you hand off the requests which are coming from the customer to either third-party applications or your own internal other applications. Could be payment integrations, could be other integrations, SaaS-based application integrations, whatever the case may be. Now, when the failure actually occurs, failure can actually occur anywhere, right? It could be a customer side failure. The network is failing, is not able to connect to the data center itself or the application itself. Or there could be a server related failure that's going to be in the application side. There could be a front end failure, middleware failure. There could be a database failure. So when a failure occurs, you have to exactly know. A failure is a straightforward problem. The problem is actually occurring, and you can actually easily figure out where the problem is actually occurring if you start troubleshooting, right? So these are all the areas where the application problem can actually occur, right? And when it comes to latency, is extremely complex. So the latency can suffer anywhere, right? So there could be problems on the customer side. He's running too many applications on his laptop or his desktop. That's why the application is slow. The browser itself is very, very slow. The network, his internet connection is extremely slow. When it comes to the inside the data center, the TCP/IP stack on the server side, it cannot handle so many number of connections, load balancing problems, proxy related problems. There could be latency problems occurring there. And inside the application stack itself, there could be a front-end latency problem, middleware transaction problems, a DNS or another third-party application latency is actually holding up all the connections. Or there could be database query related problems, writing problems. There could be several issues going on the database side as well. A latency problem from a customer standpoint is a collection of all these latencies, right? As a user, right, when I see a latency, right, it's all put together: network latency, application latency, server latency, database latency. Everything is an end-to-end latency. So you have to know the end-to-end experience of a customer, whether it is within a good limits, what you actually perceive as a user. It cannot be like more than like a few milliseconds, right? So everything has to happen in few milliseconds, the end-to-end transaction. And when it suffers, you need to know exactly where it's actually suffering. So when you start looking into causes, right? Once you identify a problem, then you start looking into causes. There could be several causes which can be occurring. There could be a user side problem. The machine itself is running out of resources. There could be issues going on there. There are problems in network side, connectivity issues, load balancing issues, routing related issues. There could be several issues going on the network side. And when it comes to proxy, again, the sessions overload can actually happen. Connection drops can actually happen. And on the server side, the resources may not be available, out of memory conditions, crashes can be occurring, CPU can be throttling, the processes could be running into errors and issues, disk related problem, read write related issues, network related issues on the server stack, TCP related problems on the TCP layer. So there could be resets going on, timeouts going on, age outs going on, and storage related issues on the server, right? And the disk related issues and so on. On the application side, when you look at the application layer, there could be front-end application issues got to do only with the UI, or it could be in the middleware business logic where the application transactions are processed, or there could be data retrieving related issues on the database side, or there could be, even if it is spread across a microservices architecture, there could be problems related to containers. They're not being spawned properly, or they're not working properly. They do not have enough resources. So there could be several issues which are actually going on in the causes, right? There could be several causes going on. And last but not the least, if there is a cyber-related threat going on, and there could be threats which are actually happening within the enterprise IT data center, somebody is trying to do an attack either from public internet, or there could be botnets which are actually running within your enterprise IT environment, and they could be causing several issues as well. Now, when you look at the monitoring data sets, right? So there are several kinds of monitoring data sets which are actually available for you to troubleshoot all these kinds of problems, and they're available in different kinds of tools. So it's a collection of all these data sets which you have to study, and the most common types of data sets which are possible are synthetic test. The synthetic test data sets is basically, for you to, there are tools which are available which will simulate artificial app transactions, right? In different geographical locations. And these are not real user transactions. These are synthetic in nature, and they only perform certain kinds of app transaction, like a web-based transaction or SSL-based transaction or a ICMP ping-based transaction and so on. And then there are logs which are actually available, which will give you a lot of indications from a server standpoint, what's happening on the application standpoint. And these are all written by the developers like yourself and many others who have developed applications. And it will give you information about the latency, the errors, and so on, right? And the real user monitoring is a method wherein you can actually inject a JavaScript in a web page where you don't have access to a server. Then the JavaScript can actually start monitoring several performance-related statistics on the web page itself. So it gives you a lot of perspectives about the UI performance, the UI components which are actually loading, and which components are being used, and what is being launched by the user, and where the suffering is actually occurring from a latency standpoint in those web components. APM agents are extremely good when you are running a complete environment where you own the application. You can put an APM agent on the application infrastructure depending on the architecture, whether you develop the framework on a Java based or a Golang or a .NET based. Depending on that, you put a APM agent, and it can give you deep application transaction telemetry as well, starting from middleware, front end, as well as on the backend database as well. Then there is network-based, packet-based datasets, which are extremely good. It will give you the trace of what's actually going on from a customer standpoint, and it will give you real network-based latency, application-related problems on the SSL layer, as well as various applications, could be DNS, SMTP, whatever you are actually running. And it is mostly passive in nature. So it is extremely passive in nature, and it can give you a lot of information about what's going on at each and every layer of the OSS stack. And NetFlow and SNMP datasets are also available if you want to use them either from networking devices, routers, and switches. And they give you ready-to-use statistics, but although they are mostly vendor dependent, some vendors they provide that, some vendors they don't provide. And you can rely on that, and you can collect statistics to see if there is any problem going on those networking devices as well. They may not give you a lot of application related statistics, but more from a layer 2 and to a layer 3 level. They cannot go anything beyond layer 3 from a data standpoint. So if you look at current monitoring solutions, there are 4 major silos. There are network performance tools which are available in the market. You might have heard many of these vendors there. They give you end-to-end performance about network. They tell you everything about network. Likewise, there are application performance tool vendors. Then there are infrastructure performance tool vendors who monitor the server, the virtual, and the physical infrastructure. Likewise, there are cyber-related threat tool vendors as well. So the amount of cost which is actually involved in buying all these individual tools, that is the one factor. The second factor is the amount of time which actually gets lost in going into all of these individual tools, bringing the information. Every tool works on a different kinds of a data set, and you cannot correlate the data. And it is your job to bring all the data together to solve like a piece of puzzle, because you are trying to solve where is the actual final root cause, right? So it takes significant amount of time, the mean time to repair, MTTR, right, when you're troubleshooting a problem. And it results in huge amount of data duplication also. Like many of these tools, they use similar kind of data sets, and they make copies of those data sets. Like many of them are packet-based data sets, log-based data sets. They're polling the servers multiple number of times. They're getting the same data, causing overload into the network and servers and performance and everything. So there is an explosion of these data sets for monitoring as well. So if you look at the challenges in an IT monitoring, as there are 2 levels of challenges. From an organization standpoint, there is increasing level of IT complexity. There's so many number of things which are actually going on. Cost-related complexities from an operational and CapEx-related stuff. Cybersecurity is a huge concern, so you will have security-related regulations and process to follow. And the company and the organization is going through a digital transformation, migrating your on-premises applications to the cloud, and you have several challenges coming from the digital transformation journey itself. And on the team side, right, so it is, you will have tool-related clutter, which you will be dealing with a lot of different kinds of tools. And every tool generates different kinds of alerts, which can give you alert fatigue. There could be conflicting alerts, confusing alerts. And if you're not instrumented certain areas of the network, there could be blind spots. As I mentioned, data explosion is another challenge. Manual data correlation is another challenge. And collection, analysis, and everything is equally another important challenge in itself. End of the day, all these challenges result in one issue, and that issue is your preparedness to outages, or your preparedness to resolve a critical IT related problem in a timely fashion, right? So the amount of time it actually takes, right? So your preparedness is extremely low. You're not confident, right, whether you can able to solve a problem in a given time frame, whether you will be able to detect the problem and fix the problem in the least amount of time, right? And it may not give you enough preparedness that you may not have confidence that when your application can actually go down. There is no way you can actually tell with confidence. You can tell that my application will never go down because I have a monitoring system. I can track it, and before it goes down, I will know that when it will go down, so I can fix the problem. And monitoring is a maturity, right? So if you look at an organization, you start from very simple things like availability monitoring. Is it my application up? Is my server up? These are very simple things. Then you start service-related monitoring, the business services, right? How the business service is working from a customer standpoint, from a revenue standpoint, and everything. And diagnostic, you should have deep diagnostics to resolve a problem end to end, like transaction tracing, call tracing, root cause analysis, and stuff like that for you to resolve a problem. And how monitoring data can help you to predict your business growth or give insights into how your business is performing. A lot of people have gone into that level of maturity today. By looking into the monitoring data, they can tell how their business is growing. Like, it can, like in like Walmart case, like they're looking at the URLs people are clicking, they can know which products are actually selling, and they can actually put those products on the top of the page, right? And they can give advertisements to customers on those pages and on those products. And last level of maturity is automation. Once you have developed a very good maturity in IT monitoring, you can automate a lot of things, you can monitor, and there is artificial intelligence where things can autocorrect itself. It is possible in the cloud. There are a lot of AIOps tools today where you can automate a lot of things and you can auto-remediate problems as well. So looking into tools, when you look at a particular tool, when you want to buy a particular tool in IT monitoring, there are several factors which will come into picture when you are making that kind of a judgment. You need a tool which provides end-to-end visibility across the network layer, application layer, infrastructure layer, as well as the cyber-related threat layer. And it removes your need for manual data correlation. The tool should be able to stitch all the data and show end-to-end what is actually going on. And the tool should provide you a lot of customization features where you can actually build your own visualizations on your metrics. So there is a lot of these existing tools today, they come with fixed visualizations and you cannot change them, right? And if you need to mix and match certain kinds of data sets to get a visibility, and there should be customization options as well. And the information what you get from a monitoring tools, it should be actionable, and you have to get evidence for you to take actions. If you don't get evidence, if you just cannot believe the tool. If a tool tells that there is a latency problem, and if there is no evidence attached to that problem, you cannot take an action. Like in case of cybersecurity, you tell there is a cyber threat going on, but you don't substantiate that with evidence, they cannot take action. And those actions can be very, very high level. They are bringing down systems, they are shutting down an application, they're pulling out the systems from the network, right? So evidence is equally important for you to confidently take actions. And it should provide seamless deployment and visibility, whether your applications are running in on-premises network, private cloud, or public cloud. It should give you an end-to-end a seamless deployment. And when you're doing digital transformation, you should be able to expand the solution, right? So you're getting visibility today in on-premises and private cloud. You should be able to extend it to public cloud environment as well. And it should help you to reduce the time it actually takes to resolve a problem, which is the mean time to repair. And best integrations, right? So integrations with respect to ticketing systems, if you want to log another ticket into your Jira ticketing system for you to track a bug, or it could be an IT service ticket for auditing, for security, whatever the case may be, there should be enough integrations possible. So at a click of a button, you can actually initiate those integrations. And it should help you to accomplish your digital transformation, right? One of the challenges today is when people migrate to cloud, they're spending money, they're spending energy, right? They don't know what is the end result. Right? When the applications are completely migrated, what is the user experience, right, of the same application in cloud. And you should be able to compare. This was the user experience for customers who are using my application in on-premises, and this is the new experience of customers who are using in the cloud. So visibility should never get lost, and you should be able to, the tool should be able to allow you to do that digital transformation successfully. And as your network grows, the tool should also should grow, right? The data grows, the network grows, application grows, server grows, right? So the tool should automatically scale, and there should not be any data explosion, right? Same data collecting a number of times doesn't make any sense. And there are business-related considerations as well from a cost standpoint, whether it gives key performance indicators for taking business-level decisions, whether it can solve all kinds of use cases, and whether it can monitor critical business services which impacts the revenue, right? That's the most important thing from considering the tool. So unified IT monitoring is a concept where you want to get a full stack IT monitoring end to end. When you look at the tool, you need to be able to see, oh, I can get network data, application data, infrastructure data, cyber related data, all in one single place. So I get visibility into everything. I don't need to go into 4 different locations, and not just visibility. The data should be correlatable. I look at a context of a problem, an application problem, a server problem, a user problem, a time-related problem. With that particular context, I should be able to switch context between application to what happened in network during the same time, what happened on the server infrastructure at the same time, what happened in the cloud at the same time, right? And more so, you should be able to do that with agentless monitoring. Agentless monitoring means you don't need to install software on your commercial application servers, which can compromise your cyber-related security, and it can compromise the performance of your servers, right? So the monitoring tools should be more passive in nature, and you can deploy anywhere, on-premise, private cloud, public cloud, and it should provide you automated analytics and a lot of integrations and visualizations. So unified visibility is extremely important. It can help you save at least 4 times time. When you look at all these individual tools, if you consolidate everything into one single solution, it can easily give you 4 times savings in time, which can be very, very important when you're dealing with a critical IT related problem. And it gives you 4 times better visibility across your entire stack, what is actually going on. And cost-wise also, it can be very, very viable as well. So I think that's pretty much it. I can actually, if you have 5 minutes time, I can actually take you across a demo. So let's take a look at time. Steve, do you have about 5 minutes for a demo?
Yeah, I think so. I think everyone would like to see what that looks like. If you've got an example.
Yeah. So let me show you an example, and then we can kick into the demonstration. Right. Let me pull the video. And here you go. So here is an example which I'm illustrating, right? So you start your IT monitoring with business service in mind. Amazon.com is a business service. It's not an application, right? You need to know in real time what is going on Amazon.com if you're sitting in Amazon's IT infrastructure, right? Thousands of users who are connecting to Amazon.com. Are they experiencing an application problem? How many users are getting impacted? Are you experiencing a cyber-related threat on that application service, a networking-related issue, or an infrastructure-related issue? That is where you actually start from an IT standpoint, right? In IT, a CIO or a CXO kind of a person and an IT director kind of a person or a VP of IT, and everybody should start looking into that business service first. That's where you start, right? So here is an example. You start with a very high-level application-related service, which could be a collection of application service. You can look at, there is an application failure rate, which is actually going on. It's giving you service-related health. And you should be able to play around with time. This is a real-time dashboard. If you look at on the right-hand side, there is last 6 hours worth of data you're seeing. Every 5 minutes, the data automatically refreshes, right? You can see the latest and greatest data. And you should be able to get a snapshot view as well as four-time trend view. Why is it both important? I look at 51% application failure rate in last 6 hours. I don't know whether it happened once or whether it happened all the time, right? So a overtime trend chart here will actually give me a perspective of how bad the problem is. Has it been a one-off an instance or it's been a continuous issue, right? That's what the overtime trend actually shows you here. And you can start investigating the problem, right? So you can click on the application failure rate right there, and you can start investigating the problem right there itself. And when you start investigating, the first thing you need to know is which is the server which is going through this problem, which are all the end users who are getting impacted. So that's the first thing you want to know, right? There are 2 end users who are getting impacted. This is the application server. How many requests have come on the server during this point in time? How many errors have actually occurred? And what is the latency which the server is actually seeing? You're not looking at an application standpoint yet, but you're looking into the actual impact of the problem, right? And then the next step is to drill down into that particular server itself, right? Which is the host, right? And you need to see both the perspectives of that particular host. That host, which is the server, can be acting like a client and can be acting like a server. Because it's a server doesn't necessarily mean that it's not acting like a client. So on the left-hand side here, you're looking like what it is actually doing as a client. It is doing some web-based transaction over HTTP. On the right-hand side, this is a server. You're looking into how many kinds of failures have actually occurred, how many number of connections have actually occurred, what is the average latency on this particular server across all applications, right? And what is the actual connections which are actually going on, what applications are actually running on the server. That is what you're actually focusing on. This server seems to be running SSL and DNS and web-based application. That's what this is actually running. And you want to see the top conversations which are actually going on the server side. And per conversation, you want to know per user, you want to know how much amount of traffic is coming, what has been the experience for a given user from a client standpoint, server standpoint, network standpoint, and so on, right? The average duration of the connection, right? Are there any networking related issues, application related issues for that particular user, and what app is running, and so on. So then you continue with the application-based troubleshooting. Next step is you have looked at the host. Now you start looking into the application. So here you are actually seeing a web-based application. That's why you're in the web monitor. You want to see what's going on the web-based application, right? So you're looking into the web-based application. You want to see whether you're dealing with the client error, whether you're dealing with a server error. And when it comes to latency, what is extremely important is to understand where the latency is suffering, right? So first you need to understand the end-to-end latency, which is end user response time. And then you need to see the breakup of that end-to-end customer experience across server latency, network latency, client latency, and application latency, right? So once you get that perspective, right, then you go into individual error codes. You want to see this is a web-based application. You want to see the HTTP error code on the front end, what's actually going on, right? You look into the HTTP error code, you look into the IP address, you look into the URL, right? And then from here, you switch into infra-related monitoring. Now you have understood there is a problem going on the server. If you suspect there is an infrastructure issue which is actually going on the server, it may not have enough resources for the applications to perform. Then you move into the infrastructure related issue. You look into which process is actually running, how many connections are actually coming, is the process related errors. There is a process, the Java is the actual process which is running that web-based application. What are the, let's stay here for a minute. So what are all the, sorry, let's stay here for a minute. So what are all the processes which are consuming the highest amount of CPU? Which processes are consuming the highest amount of memory. Then you want to go into more details. Then you want to go into the overall server side, what's going on, free memory available, peak memory available. You need to know about the infrastructure as well, the total disk size available, how many CPUs are actually available, right? So you can look into all those things. You can also look into the disk usage as well, right? So if you want to see if any of the storage partitions are actually running out of space, which storage partitions are running out of space, mount points, file systems. So these are the things which you want to know. The next logical step is to look into cyber-related threat angle, right? You're not gone into deep into the application yet. You're looked into a very high level on the application. You're looked into the infrastructure. Now you're looking into cyber threat perspective. Are there any cyber threats which are going on the same server? Where the cyber threat is actually coming from? What kind of cyber-related threat you're actually dealing with? Right, whether some kind of a scan is going on, brute force attack is going on, DDoS attack is going on, right? And then you should be able to investigate those threats as well, right? If any of the threat is actually causing the problem, right? And last but not the least, you want to now deep dive into application, right? So you can actually go deep into the application. Now you have seen the URL. You can actually see the individual URL, and then you want to see if a particular web page is taking the most amount of time. You want to go deep inside the application using an APM related agent, right? So you can click on a particular URL, and now you have a context of a URL, you have a client IP address, you have a server IP address. Now you are going to deep inside the application. So now here you jump into the, if you go down a little bit here, so you look into all aspects of the application. Now you have a lot of information. You are dealing with the Java process, what kinds of transactions are going on the application, the type of the transaction which you're dealing with, what kinds of browsers are interacting with the application, operating systems where the clients are coming from, right? You'll see the actual the transaction itself, right? The actual transaction internal to your application. What is the transaction which got invoked, right? And you can see the latency of the transaction. And now you will go deep inside the transaction. When this web transaction came into the application server, it might have resulted in a lot of sub transactions on your middleware, right? So here is all your sub transactions. Some of them went into this is a Jira based application. There's a H2 database here. So you have H2 database. A lot of queries are actually going on. You want to see which query is taking the most amount of time, which web transaction, middleware transaction is failing. And if you have even a database, you can go further deep inside, and you can go and study individual queries as well. So you can select a particular database query. You can see how many rows are getting impacted on the database. You can deep dive inside the transaction. Yeah. So I don't have a picture of that. So you can actually deep dive inside the database transaction. You can get to see the actual query which went into the database and the latency and the exceptions which occurred on the database as well. So this is going into deep inside the application, right? So you can figure out what's really going on the application side. So that's very much about the demo. And let me just stop this, come back here, and conclude the session. So basically the bottom line is you need to have the right amount of tools, right, which can put together all the information. A unified IT monitoring solution can actually really help you to bring together an end-to-end perspective of a problem, an IT-related problem. What's going on the network, application, infrastructure, cyber threat, end-to-end, for you to understand the problem, the impact of the problem, and isolate the root cause. So that's pretty much it I wanted to cover, Steve. You can open up for questions.
Sure, thanks. So I have a question. Like, if you go back to your demo, the first thing that I see when I look at that base dashboard screen is pretty common. Like when I look at any kind of operational dashboard, it's just like a wall of red, right? Like you just see everything. Exactly. So this screen, there's just so many things. How are you looking at this and picking out something to go and chase down? Like, are you able to actually diagnose an issue by looking at this, or are you looking at this after an issue has been raised through support or customers?
So typically, nobody wants to see a dashboard. Nobody has time to sit and watch a dashboard, right? So everything has to be alerted. So all these things, what you see here will translate into alerts, right? And you can configure what kinds of alerts you want. Like you can set your thresholds and everything, and only which match those thresholds will be alerted on the email. And when you click on that email, you'll come to this workflow, or there are several workflows in the system which you can directly deep dive into, right? So you have to focus on the problem, right? This is only for NOC, right? Somebody who is at a NOC engineer, this is not for a DevOps, right? So this is for a NOC engineer who is sitting and monitoring a lot of application services across the entire IT stack. And he wants to monitor everything, and he gets a perspective. He doesn't know what's going on. He has to identify the problem and then give it to a right engineer, whether it's an application engineer or a security engineer, right? And he can make very good decisions with the correlated data right here, right?
Got it. That makes sense. Anybody else have any other questions? Jump in the chat or take yourself off mute. Feel free to ask whatever you like.
Hello, thank you for the presentation. It's very interesting to see, essentially it's built for a person who can understand the network from like high level, from networking down to the application level, down to the like particular SQL queries. Is it right to say?
Yes. So this particular tool, whatever you're seeing, it collects the data end to end. Yes. And it is not an integration, it's not an integrated tool. It's not like you need 4 different tools and you need a 5th tool which integrates on top of the 4 tools. No, this is one solution which has its own data sets. And you don't need to buy 4 different tools to make this tool work. No, this tool is a self-contained tool. It has its own network data sets, infrastructure data sets, cyber threat data sets, as well as application data sets to show this information.
Mm-hmm. I see. And does it exist, or it's like still like demo work in progress?
No, this is a commercial product. I mean, we sell this product. Yeah.
Mm-hmm. I see. And what do we need, like on application level, for the tool to know to go to the down of queries, down to the lines of code? Do we need to install some kind of agent?
Yeah, so you need different kind of sensors, right? So the data sets, what you see, all these data sets, whatever you're seeing comes from packet-based data sets. So let me show you that. So these are all data sets which are coming from raw packets. And once you switch from here to infra-related monitoring, this data set comes from logs remotely, which means that you can actually do an SSH query or a WMI query for a Windows-based system, and you can gather all this information from the server. So this is coming from another sensor. So it's all from a user standpoint, it's all correlated. In the background, I'm just telling how this thing is actually working. In the background, this is another sensor. This is a second sensor which is bringing infrastructure related information. And then we have a third sensor, which is the APM sensor. So in the network side, it can only tell you SSL because it only sees encrypted packets. It doesn't know what is there inside the encrypted payload, correct? So if you need to see inside the application payload, then you need to put a APM sensor on the application server, right? Mm-hmm. And that will actually show you all the URLs, all the transactions, database queries, and everything. So whatever you saw in the APM dashboard here, this is coming from the APM agent. This is the third sensor. So whatever data you saw is a combination of 3 different sensors: a packet-based sensor, a log-based sensor, and an APM-based sensor, all of them stitched in one single workflow.
Mm-hmm. Okay, thank you. Yeah, that's impressive. Thank you.
Manjunath, what's the closest open source equivalent to this that folks could play around with or test in parallel?
Yeah, there is no open source tool, unfortunately. Everything again is broken, small. You have an open source tool for network, for application, for server monitoring. Everything is individual. You don't have an open source tool today which combines everything. You'll have to build your own. And there are visualization tools, the likes of Grafana and others. So you'll have to do a lot of work in building a middleware structure and then a UI structure on top of it to integrate those tools, individual tools.
Okay, so something like Grafana and Kibana and Elasticsearch could get you started, but you're still going to have. What are the main challenges with kind of a homegrown solution?
Yeah, so challenges is basically stitching, right? You have the data, you can visualize the data, but the way I showed you, you cannot stitch like that. That requires you to correlate the data at a middleware layer, correct? You can like in Grafana, what you can actually do is you can put multiple tools together and you can visualize, and they're all individual screens, right? And one is coming from Splunk, another is coming from App Dynamics, another is coming from Dynatrace, another is coming from SolarWinds, whatever, right? You can see them all in different dashboards, but not collectively as an experience when you're troubleshooting like a step by step, right? That is possible, but you'll have to buy all those individual tools and then you do it in Grafana yourself with a visualization, right? So yeah, that's the work which will be involved.
We have one question from Nawaz about whether you've seen a telco use case for this.
Yes, so telco use case is predominantly, everything is IP, right? I showed you an application, and when you go back here, these particular services, what we work with service provider customers also. I've given you enterprise application services here. In case of a service provider, it could be mobile applications, it could be your access service, access layer services, RAN services, it could be authentication services, right? It could be even various kinds of interconnecting multi-services. It could be anything, right? It's all the data set is the same, right? Packet-based data sets, they're also in service provider world, log-based data sets and everything. The same solution works in service provider environment also. But we don't, from ThoughtData perspective, we don't work with service provider customers because there is a lot of data which you need to churn, parsers which you need for service provider protocols, primarily GTP, right? There are hundreds of protocols in service provider 3GPP stack. So we don't do that. So we are not into service provider market. Nobody has tried to consolidate this in service provider yet, but we are doing it only on the enterprise side right now. We are focused on enterprise, not on the service provider side yet. But it is same concept. My vision is to expand into service provider world someday. I have experience in service provider market as well, but that's a far-fetched goal for us right now. Any other questions?
Last chance for questions.
Thank you so much. If there are no questions, Steve has my contact ID. If anybody is interested to know more about us and everything, feel free to touch base with us. Happy to help you out in whatever problem you're trying